Assalamu alaikum and hi everyone. My name is Mohammad Salman bin Ahmad Pertala Rimba. My metric number J25A1712. My part of the presentation is the introduction to analytical chemistry. Let's start with the basic question. What is analytical chemistry? Simply put, analytical chemistry is the science of measurement and identification. It involves a set of powerful methods used to determine what a sample is made of. That's the qualitative analysis, and how much of each component is present. That's the quantitative analysis. In a sense, it's the chemistry that asks the question, what is it and how much is there? Now, why is this important? Analytical chemistry isn't confined to a lab. Its applications touch almost every aspect of our daily lives. In medicine, it's used for diagnosing disease through blood and urine tests. It measures glucose, cholesterol, and drug levels, ensuring accurate patient care. In food safety, it verifies the nutrient content list on a food label, which the amount of protein, fat, and sugar. Crucially, it detects harmful contaminants like pesticides or heavy metals, making our food safe. In environmental monitoring, it helps us assess the quality of our air and water. For example, it measures pollution in river water to ensure it's safe for the ecosystem and human consumption. This is vital for managing our resources. In forensic science, it's the key to analyzing DNA, fibers, and trace evidence found at a crime scene. Let's look at one specific real-life example where analytical chemistry is critical, which is ensuring our drinking water is safe. When water treatment plants send water to our homes, analytical chemists use various techniques to check for contaminants. They measure tiny amounts of chlorine to ensure it's disinfected, and they look for undesirable substances like lead, mercury, or bacteria. For instance, they might use a technique called spectroscopy to measure heavy metal concentration at the parts per billion level. The quantitative analysis allows regulators to ensure the water meets safety standards before it leaves the plant. This is direct, critical example of analytical chemistry protecting public health. In short, analytical chemistry is how we measure and identify the world around us. Now that we've seen why these measurements matter, I hand it over to Hairullah to show us the first method of measurement, which is volumetric analysis. That's all from me. Thank you.
Okay, hi, Assalamualaikum and very good morning. Today I will explain about volumetric analysis. It's a focusing on draination technique. So, volumetric analysis is a method using to find the unknown concentration of a solution. So, concentration work by reacting a solution of no concentration with an unknown solution until the reaction is complete. This method is based on stoichiometry and require accurate volume measurement. Okay, so on this diagram show filtration setup. So the burette contains the standard solution, while the conical flags contain the unknown solution and an indicator. During transition, the solution is added slowly until the color change, showing the end point. So we going next to our next slide. So this is example for HCI concentration example. So in this example, we using 25 milliliter of HCl is generated with 0.1 0.100 m NaOH, or we call it NaO. The average volume of NaOH using is 30 milliliter. So the calculation, the balance equation is HCl plus NaOH plus equal to NaCl plus H2O. First, calculate the moles of NaOH. So moles equal to 0.1 times 0.03000 equal to, we get the mole is 0.00300 mole. Since the reaction is one and one, the moles of HCl is also 0.00300 mole. So the concentration of HCl is 0.00300 divide by 0.02500. So we get 0.120 mole. So the conclusion is titration is a reliable method to determine unknown concentration. From this experiment, the concentration of HCl is 0.120 m. Thank you for your attention. That's all from me.
Now moving on to the third section of our analysis, which is titric analysis. If you look at the diagram on the left, most of us recognize this classic setup, the burette and the flask. But what is actually happening here? In simple terms, titric analysis is a method where we determine the exact amount of unknown substance called the analyte by reacting with specific volume known as substance, called the titrant. Until the reaction is complete, we call that completion point the end point. Now, a common question is this the same as volumetric analysis? As you can see on the slide, there is a key difference. Volumetric specifically focuses on measuring volume. However, titric is broader scope. It encompasses any analysis based on titration, which includes acid-base redox, precipitation, and complexometric titration. To make this concrete, let's look at a practical example using redox titration on the next slide. In this scenario, we are using potassium permanganate to find out how much iron in our solution. Here is data we have. Given moles, we use exactly 0.02 mole of permanganate. The ratio, the chemical equation tell us these two react in 1:25 ratio. This means for every single molecule of permanganate, we use 5 ion of iron. So the math is become very straightforward. We simply take our known moles 0.02 and multiply it by a ratio factor which is 5. This gives us our final result. 0.1 moles of iron was required for this reaction. This simple calculation allows us to quantify unknown sample with high precision.
Assalamualaikum and good morning. My name is Mohammad Yusuff bin Abdul Latif. My number matrix is J2581495. Today I will continue this slide with my parts. We will look at the importance technique in analytical chemistry, called gravimetric analysis. Gravimetric analysis is a quantitative method based on of the measurement of a mass in the technique. We measure the mass of the per solid product from a chemical reaction. This product must be stable and have a now composition so that we can accurately calculate the amount of the original analyte. This method is a very well known from this height actually. By using the analytical balance as the show in the picture, we can ensure the mass of measurement are carried out by carefully and consistently. In analytical chemistry, gravimetric analysis plays several key roles. First is used for purity testing, that is, determine whatever substance contain the desired component in the current amount. Next, it's also used to determine the concentration of ion in a solution from example, chloride of solution ion, sulfate ion. In conclusion, gravimetric analysis is a very useful technique in laboratory analysis because it's very accurate, reliable result, especially when high quantitative verification is required. Now we continue to the next slide. Now we will see how gravimetric analysis is used to calculate the mass of chloride ions in a sample. A sample contains chloride ion and when reacted with a silver nitrate AgNO₄ solution, a wild precipitate of the silver chloride AgCl is formed. In this experiment, 0.143 grams of AgCl was obtained. The first step is calculate the moles of AgCl formed. We use the formula N equal M per capital M's, where is M is the mass of AgCl and capital M is the molar mass of AgCl. So N equals 0.143 gram divided by 143.32 G per mole equal 0.000998 mole, which we round to 0.000100 mole. Next, we know that in the reaction, the ratio between AgCl and Cl is 1:1. So the total moles of Cl is also 0.001000 mole. To get the mass of chloride ion, we use the formula M equal N D times M, where M for Cl is 35.45 J per mole. So M equals 0.000100 times 335.45 equal 0.03545 gram. Finally, we round it to 0.035 gram. The mass of chloride ions in the sample is 0.035 gram. This method demonstrated how gravimetric analysis can be used to determine the ion content in the solution with high accuracy simply by measuring the mass of the solid product formed. That's all for my team. Thank you. See you in the next time.